Hey guys, it's Rishi once again, and today we're back with Venn diagrams. But what are Venn diagrams? Well, a Venn diagram is a way of grouping different items. Now these groups are known as sets. And we have a set of golf clubs or a set of dishes, and these are just groups of those items. Now, we write a set using a special type of brackets. And now you could have a set of friends, for example, Tom, Leanne, Alison. But notice, within these, we do not use capital letters. And the types of brackets we use are your curly braces. So as I mentioned, you could have Tom, you could have Leanne, and you could have Alison. So we don't use capitals, and we use our curly braces. Now a Venn diagram begins with a box called our universal set. So this is our box and it's labeled as our universal set. And that's a symbol called the epsilon. And there we are. And now the universal set simply contains everything that we are interested in at that particular time. And there'll be circles inside the box, which we use to group the items within the universal set. And items in the circles then form different subsets. So you can see we have our set A and our set B. And let's put some random digits in here. So now, as you can see, set A is the numbers in the circle labeled A, and set B is the numbers in the circle labeled B. So let's take a look at what we have in set A. So we'll take our curly braces and we'll write down all of the numbers in order. And then for set B, we'll do the same. And there we are. And these are the subsets of the universal. But let's now dive into the intersection. So the intersection is where we have the items from set A and set B. And these can be in the section that overlaps. So if I go ahead and take a different color, it's all of this section here. As this is the section that overlaps, this is seen as your intersection. And we write it as A intersection B. And in the example that I've just given you here, our A intersection B will be equal to 6, 7, 9, and 12. And that is how we would write it using our curly braces. And then the final part is the union. Now the union of a Venn diagram is the numbers that are in either set A or set B. And so the union of this example would be all of the numbers in set A and B without the duplicates. And as you can see, we've got a 12 in set A and a 12 in set B. If we were to now go for the union, which is the entire section here, we would have A union B. So again, the symbol is similar to a letter U. We'll take our curly braces and write down every single number, which is number 1 all the way to 13. And there we are. So we've got our intersection, which is where they both overlap. And we have our union, which is either set A or set B. Marvelous work. So I hope that was a quick introduction into Venn diagrams. But let's now go ahead and dive into these questions and let's see what we come across. Question number 1. Given that PA equals 0.9, find PA with an apostrophe. So what does that mean? Well, when you have an apostrophe alongside the A, that means not A. And as we know, our probability is out of one whole. If we have the chance of getting P, which is 0.9, then the chance of not getting P has to be 0.1, because you know that one whole minus 0.9 gives us 0.1, and that is our answer. So once again, where you have a letter followed by an apostrophe, that is then meaning not that specific letter. Marvelous. Let's go for question number 2. Shade the region that represents A intersection B. So once again, if you remember, intersection was where both sets overlap. So we now know it's going to be the middle section here. That is your A intersection B. But question 3 is now asking us for the union. And if you remember, the union was either all of the items in set A or set B. So we will now go ahead and highlight everything in detail. And there we are. So I hope you're understanding how we are doing this and why we are doing this. Okay, question number 4. Let's shade the region that represents not A intersection not B. So that means everything that is in not A and not B. And that just means it's going to be the entire surrounding of A and B, because it's stating not A and not B. So please remember, that means not A and not B. Okay, question number 5. So not A, but union B. So as we know that it's asking for the union, that is either A or B. But in this case, it's stating not A, but everything else. So in this case, we'll start off by doing our union B. And then we'll go ahead and do our surroundings. But we are not going to touch the contents of set A. So once again, not A, but union B, which is everything else. But now in question 6, it's asking us to shade the region that represents A intersection not B. So again, we're going to leave B. If it says not B, we don't touch B at all, but we'll have our A intersection. I hope that was a useful introduction. Let's now dive into something a bit more problematic. So here we have our problems. 40 students were surveyed, and 20 have visited France, 15 have visited Spain, and 10 have visited both France and Spain. So let's use this information to complete our Venn diagram. So the main top tip here is always to start off with the intersection. That is what is shared between your sets. And we know that 10 have visited France and Spain, so we'll go ahead and write 10 in the middle. We then know that 15 visited Spain, but out of the 15 that visited Spain, 10 is also within that set. So we know we'll have 15 minus 10, which gives us 5. So once again, 15 visited Spain. And if I just draw a ring around Spain, if we add up 10 and 5, that gives us 15. Hence, I had to put 5 in just the Spain set. And then finally, we can see that 20 people visited France. And because we know that 10 have visited both France and Spain, we simply have 20 minus 10, which gives us 10, and that is in our France section. And now for the final part, we see that there were 40 students that were surveyed. And now if I add up the total of all of the people within the set France and Spain, we get 25. So we'll then have 40 minus 25, which gives us 15. And that there would be in our universal set, which shows that 15 have neither visited France or Spain. And let's now dive into question 8. Once again, feel free to pause the video at any time, attempt the question, and then press play. Okay, let's keep going. Out of the 50 people surveyed, 30 have a brother, 25 have a sister, and 6 have neither a brother or a sister. Well, if we know that 6 neither have a brother or sister, we can put that outside of the set. We then need to go ahead and add the brother and sister. So we know 30 plus 25 equals 55. We now need to work out of the 50 people who has both a brother and a sister. And the way we're going to do that is by simply subtracting the 6 away from the 50 because 6 have neither a brother or sister. And that gives us 44. So now we know we'll take our total amount of people, which is 55, and minus 44, which gives us 11. So this means that 11 people both have a brother and a sister. And now we have this, we can go ahead and calculate the brother set as well as the sister. So we know that 30 people have a brother. So if we simply have 30 minus 11, which is our intersection, this gives us 19. So we now know that 19 people just have a brother. We will go ahead and do the same for our sister. So we'll have 25 minus 11, which gives us 14. So we know that 14 people just have a sister. And that is our question complete. A quick 3 marks there. Go ahead and always start by working with the intersection or what is left out. Once you've got the intersection, that will then help you out to figure out the other sets. Okay, question 9. So now we need to go ahead and draw out our universal for this question first. And within this, we know we're looking at tea, coffee, and milk. So again, we'll go ahead and draw 3 sections. We'll have tea, coffee, and milk. We know that there are 50 people who at least like one of the drinks. And we know that 19 people like all 3 drinks. So we can put 19 in the middle there. And 16 people like tea and coffee, but not milk. So tea and coffee is here. So we put 16 at the top. We can tick that as well. And 21 like coffee and milk. So if 21 like coffee and milk, we're going to put a 2 here. And that is because 19 plus 2 gives us 21. And that is between milk and coffee. We then see that 24 people like tea and milk. So now we've got tea and milk. And that is going to be this section here. So we're going to put a 5. That is because we know that 5 and 19 equals 24. And then it states that 40 people like coffee. So if we have 16, 19, and 2, if we add that together, that is 37. And if we have 40, take away 37, that gives us 3. So we now know that there's only 3 people that just like coffee. So I hope you're seeing how I am breaking this down and calculating each specific section. And then we know that 1 person only likes milk, and we'll put the 1 there. Marvelous work. So now let's go to the final part. And that is that Sami selects at random one of the 50 people. And work out the probability that this person likes tea. So I'm going to go ahead and add all of the values from tea, which is 4 plus 16 plus 5 plus 19, which gives us 44. I will then go ahead and write this out as a fraction, as it's asking me for it, which equals 44. So now we need to work out the probability that this person likes tea. So we know our total is 44, and that is going to be 44 out of 50, as it was 50 people they had asked. And there we are. So I hope that question was clear. Let's now move into question 10. So Sami asked 60 people which sports they liked from rugby, football, and cricket. So again, we're looking at 3 different sets here. So I'll go ahead and draw that out. So once again, that's rugby, football, or cricket. We know that 8 people like all 3 sports, so that will go in the center. We know that 17 people like rugby and football. So we know that 9 plus 8 is 17. So we can go ahead and write that out. Once again, I've done 17 minus 8 to give me 9. We then know that 13 people like football and cricket. So if we have 13 minus 8, this gives us 5. So we know 5 is for football and cricket. And now we have 19 people that like rugby and cricket. So again, we have 8 already in that position. So we'll have 19 minus 8, which gives us 11. And that goes in the rugby and cricket section. And 35 people like football. So we will now have 35 minus all of the three numbers, which is 9, 8, and 5. And that will give us 13. So we can write 13 in the football section. And 27 people like cricket. So once again, I'll go ahead and write 27 minus 11, 8, and 5. And that there will give me 3. So I can write 3 in the cricket section. And then we have 30 people like rugby. So again, we'll go for 30 minus 9 minus 11 minus 8, and that gives us 2. And that's now filled out there. And then it states how many people liked neither rugby or football or cricket. So now we need to add up all of our numbers and then subtract it from 60. So if we go ahead and do that, that gives us 51 as our total. But out of the 51, 60 people were asked. So if we get our difference, that gives us 9. So our answer here is going to be 9, and we can also put that in our universal set as 9 people like neither rugby or football or cricket. So once again, I hope you can see how I've gone ahead and attempted this question, breaking it down into simple steps and crossing out each and every one of them as I go through them. Let's keep up the great work and let's move into question 11. So now in question 11, we have our epsilon, as you can see at the top here. And we know the epsilon is a set which has even numbers between 1 and 31. We have our subset A and subset B. And we now need to complete the Venn diagram to represent this information. And it states a number is chosen at random to represent this information. So now let's go ahead and write this out. So let's start off with our intersection, and that is again the digits that are both shared between set A and set B. We can see we have 8, which will go in the center, and we will have 18, which will also go in the center, and 22. We will then go ahead and fill the rest of the sets up with the individual numbers. So for set A, we will have 2, 4, 14, and 28. And for set B, we'll have 10, 16, and 30. And then outside of these sets are the numbers that are not included. It still remains within the epsilon, but just outside of our set. And that again would be 6, 12, 20, 24, and 26. Once again, if you want to double check this, please go ahead and write out all of the even numbers between 1 and 31. And that there will leave you with these as the numbers left over. But for part B now, it says a number is chosen at random from the universal set. And what is the probability that the number is in the set A union B? So that means we need to add up all of the numbers in both of our set A and B. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we know that is going to be 10 over, and if we add up the remaining, that's 11, 12, 13, 14, 15. So we know it's 10 over 15, and that's the probability of the set being A union B. I hope that was clear. Let's go ahead and dive into the next question. So now they've given us a Venn diagram, and they're asking us to list the members of A intersection B. So that is everything in A and B. So if we go ahead and highlight this, you can see A and B share 3 numbers, which is 1, 3, and 8. And then for part B, it states a number is chosen at random from the epsilon. So find the probability of B union C. So that means all of the numbers in B and C. So let's go ahead and add these numbers in B union C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know there are 10 numbers in set B and set C. And there are 12 in total as we have 6 and 9. So that's going to be 10 over 12. And now let's go over to our final question. Question 13. You've done amazingly well by coming this far. And I hope you've paused the video, attempted the question, and then pressed play to watch me go through the solutions. Don't forget that repetition is key. So if you need to watch this over again and attempt the questions, please do so. Right, so for question 13, we now have our epsilon, which is the odd numbers less than 30. And we have the numbers directed to each set A, B, and C. So let's go ahead and fill these out. So like always, let's go ahead and start off with ones that are duplicated. We have the number 7 in all of the sets, so 7 goes in the center. We then can see that 29 is shared between A and B, so we can put that in between A and B. We then have the number 15, which is between B and C, so we can put that here. And we know 11 is the only one left in B, so we can put 11 in set B. We then have numbers 1, 5, and 23 in A. And we're left with numbers 17, 19, 25, and 27 in C. So that is all of our numbers used up. But we still have numbers 3, 9, 13, and 21 that are in neither A, B, or C. So that's our Venn diagram completed. And now let's dive into our part B. And that states that a number is chosen at random from our epsilon. And we need to find the probability that is a member of A intersection B. So that means we need to find all of the numbers that are intersecting between A and B. And you can see that our intersection would only cover these two numbers here, which is 29 and 7. So on that basis, that would give us 2. But what would be our total? And again, the total would be the number of digits we have in our entire universal. So if we add all of the numbers here, we can see that there are 15 numbers in total, and that would be 2 over 15. And there we are. And that there brings us to the end of our session. I hope you found this topic useful. Remember, this is a useful tool in the world of statistics. Once you have got to grips with these, you will be able to arrange all sorts of groups and sets. And as you've seen, it's possible to have Venn diagrams with 3 subsets. You guys have done amazingly well for coming this far. And remember, you may even be asked to solve problems using Venn diagrams in your exam. So it's really important that you draw the Venn diagram and add the information as you go along. This will help you to keep an overview of what is going on. With that in mind, I hope you can subscribe and share our videos. Please feel free to comment below on what more I can do to make our videos more useful to yourself. But keep up the great work, and I'll see you in the next video.